Welcome back to our next session. Here we are going to look at some of the examples of questions you can be asked in the exam. So like here I have the first question. A piece of marble chips, calcium carbonate, is put in a beaker containing excess of dilute hydrochloric acid, which is placed on a reading balance. The mass of the beaker and its contents is recorded every 2 minutes as shown below. So here there's a piece of calcium carbonate, that is marble chips, that is put in a beaker, and that beaker they add excess dilute hydrochloric acid. Then they place in a weighing balance, in a reading balance. Then the mass of the beaker and the contents are recorded every 2 minutes. So they are recorded below. So there is time, then there is mass in grams. So 0 minutes. So the time they are taking the contents there, the mass of the contents were 126.4 grams. So after 2 minutes, they were now 126.3. This one was 0.4. This one is 0.3. So kuna reduction in mass. Then after another 2 minutes, 126.2, it has reduced. After another 2 minutes, 126.1. After another minute, 126.0. Another 2 minutes, 126.0. So it's constant. Then after another 12 minutes, 126.0. So even if they will add another 2 minutes, it will just be 126.0, 126.0, 126.0. So you can see the mass is reducing, then remains constant. So the first question, why is a continuous loss of mass of the reaction mixture? Why is there a continuous loss of mass of the reaction mixture? Why is the mass reducing? Yes? Good. So I hope you have the right answer. They are saying that the mass is reducing. Why is the mass reducing? It's because carbon dioxide formed is escaping. So here there is what you call there is an acid here, and then there is a carbonate here. So we learned this one on the topic salt, or not necessarily not salts, but a topic in Form 1, the acid, bases, and indicators. You learn the properties of acids. You say that when an acid is a substance that reacts with the carbonate to give a salt, carbon dioxide, and water. So if they're reacting a calcium carbonate with an acid, with an acid. So we are expecting how many products? 3 products to be formed. There will be salt, there will be water, and there will be carbon dioxide. And we know carbon dioxide is an acid, is a gas. So meaning it will escape in the atmosphere. So when the reaction takes place, there is carbon dioxide that is formed from this reactant that is escaping from the atmosphere. So the mass of carbon dioxide is the one that is reducing. The one when it escapes, now the mass of the whole contents reduces. Then another question, write an equation for the reaction that takes place. So we know this is an acid, a mineral an acid, that is hydrochloric acid reacting with a carbonate. Can you write the reactions? We have said that there are 3 products that will be formed. Write somewhere a chemical reaction for this. Then balance. Good. So mark for yourself if you are okay. So it is calcium carbonate reacting with hydrochloric acid to give calcium chloride as our salt, then water plus carbon 4 oxide. Balancing the equation, calcium on the reactant side is 1, calcium 1, carbon 1, carbon 1 on the product side. Oxygen is 6 on the reactant side, then on the product side is also, is it 6? No, it is 3. On the product side is 3. It's 3 on the product side and is also 3 on the reactant side, so it's balanced. Then hydrogen is 1 on the reactant side, then on product side is 2. Chlorine is 1 on the reactant side, then chlorine is 2 on the product side. So you have to balance by adding a 2. We're adding a 2 here on the hydrochloric acid. Then another question, state, okay, wait. Okay, fine. So state 2 different ways by which the reaction could be have made rapid. How do we increase this rate of reaction? So we have talked about factors that increase the rate of reaction. So how can we increase the reaction of this process? We have talked of temperatures. If you increase temperature, the rate of reaction increases. So we make the reaction rapid by 1, increasing temperature. What's the other thing? Now we talked about the concentration. Increase in concentration increases the rate of reaction. So we can make this reaction more rapid by increasing the concentration of hydrochloric acid. So we say the concentration will make the particles close together, increasing the collision frequency, which increases the rate of reaction. Then also, we can do what? We could talk about surface area. Increasing the surface area increases the rate of reaction. And we said surface area affects the reaction, what we call the hetero. It affects reaction that involved two physical states, maybe a solid and a liquid, and mostly those reactions that involve solutions. Maybe a solid reacting with a liquid, or a solid reacting with a solution. So that's where surface area, that's the type of reaction that surface area affects. So if you are using such type of reaction, just like ours, hydrochloric acid is in solution form, then marble chips or calcium carbonate is in solid form. So we can increase the rate of reaction by increasing the surface area in contact with the acid. So we can increase the surface area in which the calcium carbonate is in contact with the hydrochloric acid. So we can use powdered calcium carbonate instead of marble chips. You crush these marble chips into powder. So crushing will increase the rate of reaction. Any other way? We say that pressure also affects the rate of reaction. But we were very keen. We were talking about pressure. We say that pressure only affects reactions that involve what? Gases. So if you have your answer as increasing pressure on this, it's wrong. Pressure only will affect the reactions that involve gases only. Gases as reactants in gaseous state only. So another factor that affects, we talked about a catalyst. So there's no catalyst that can do what? That can speed up this type of reaction, because these are carbonate and HCl. So there's no catalyst. In the last session, we have just looked at some catalyst reactions. Some reaction that requires catalyst. So this one is not one of them. Then, so those are the most appropriate answers. Then why does the mass remain constant after 8 minutes? After 8 minutes, tunaona the mass is remaining constant. So here, we are using marble chips, calcium carbonate, and with excess hydrochloric acid. So meaning the reaction will take place, then after some time, all the calcium carbonate will have used up. So if there are no more calcium carbonate, the reaction will stop. So if the reaction stops, no more carbon dioxide that is being produced. So meaning the rate of reducing will also do what? Will also stop, because no more carbon dioxide is coming out. So the mass remain constant because all the marble chips or all the calcium carbonate have been used up in the reaction. So, or you can just say the reaction has come to an end. The reaction has come to an end. Then state the observation that will be made if a few drops of silver nitrate solution was added to 1 cubic centimeters of resulting solution, followed by ammonia solution. Nasema state the observation that would be made if a few drops of silver nitrate solution was added to 1 cubic centimeters of the resulting solution. Followed by ammonium solution. So we know the resulting solution has a salt, calcium, calcium chloride. It has a calcium chloride as a salt. Then there's also traces of hydrochloric acid. There's also traces of hydrochloric acid. So when they react, the traces of acid reacts with what you call silver nitrate. Reacts with silver nitrate. It will form what you call silver chloride. It will form silver chloride. And you remember in Form 2, when we are looking at solubility of salts, we say that silver, all chloride salts are soluble except the chlorides of lead and silver. Except the salts of lead and silver. So silver chloride is insoluble. So meaning the observation there will be formation of silver chloride, which is soluble, which will appear as a white precipitate. So meaning a white precipitate will be formed. Then I was saying if the resulting solution is followed by ammonia, we know silver chloride dissolves in excess in ammonium solution. So the white precipitate formed that will dissolve in ammonia solution. Will dissolve in ammonia solution. The other question, the experiment was carried, there's an experiment there on Kwambi, it was carried out as follows, and the volume of hydrogen gas evolved measured at an interval of 10 seconds for 100 seconds. So there are two curves there. They are for those two solutions. So in the first experiment, they used 8 cubic centimeters of magnesium ribbon, which was added to 1 m hydrochloric acid. Then there was another experiment, they used 8 cubic centimeters of magnesium ribbon, which was added to 0.5 m hydrochloric acid. So compare the two. They are using same size of magnesium ribbon but different concentration of hydrochloric acid. There is 1 m hydrochloric acid and 0.5 m. So in the first experiment in A, the concentration of in the solution is more concentrated than solution in 2. Then the graphs, wanakuambia graph of volume of hydrogen gas evolved against time was plotted. So volume of hydrogen gas in cubic centimeters on the y-axis, then there is time in seconds. Then the graph was drawn. They gave you so they gave you I mean graph A and graph B. Then so the first question, which of the graphs was obtained for the reaction I? The one with high concentration. Between A and B. What's your answer? What's your answer? So I'm saying it's B because reaction is faster. So in B the reaction is faster. The one that is at the top. So when you compare the graph of A and B, the volume of hydrogen gas produced. So at the starting point, the volume is same. But as the time goes, the volume of hydrogen gas increases, is always higher in B than A. That's why we are saying the reaction is faster in B. Look at the graphs. The volume of hydrogen gas produced when you are looking at the y-axis on both the graphs. So they are at the same point at the starting. But as the process proceeds, B increases more rapidly than A. A iko chini, then B iko juu. So meaning there is more hydrogen gas produced in B than in A. So we are saying that that B is the one where a more concentrated acid was used, because we have learned that concentration increases the rate of reaction. So reaction is faster in B. The acid is more concentrated. The rate of reaction is faster. So that's why the graph is more steeper. Then explain the general shape of the graph. We are saying the rate of reaction is faster in the beginning due to high concentration of the reactant. So at the beginning, the reaction is faster. Then it goes at constant rate at the end, because now the reaction becomes less concentrated. The reactions zinaenda zikiisha. So huko mwisho the reaction is slower because the reactants are now less. Then the other question, they are saying they study the equilibrium reaction. They have given you some reactions. Just want to look at the first question. They are asking to suggest 2 ways of increasing the yield of A. So when you look at the reactants, I mean the process, they are both gaseous. A is in gaseous, B gaseous, then the product is also in gaseous state. So meaning pressure will affect. So when we increase pressure, the yield will be increased. Also temperature is an exothermic reaction. So in terms of temperature, we shall look at it when we'll be dealing with what? With chemical equilibrium. Then the very last question. The last question is just a graph. The level diagram of a reaction given below. What they're asking there's a reaction there. Sulfur 2 plus oxygen to give sulfur 6. Sulfur 4 plus oxygen to give sulfur 6. Then the question is, state the ways of increasing the yield of sulfur 6. So this is one of the processes in tumesema. It uses what you call vanadium 5 oxide catalyst. So we can use a catalyst which is vanadium 5 oxide. We can increase the pressure because all the linear are in gaseous state. Then we can also reduce temperatures, low temperatures. So we know the optimum conditions for the conduct process. This conduct process, we shall also look at it when we be looking at chemical equilibrium. So bye. Let's meet in our next session.